Just a snapshot of what we do in the faculty. I'm sure the dean will also speak a little bit, just to say a few words here and there, break the ice. Essentially, what we are trying to do here, let me now share a couple of our, I would say, side with you, what we sort of do here in the faculty in terms of STEM technology. So I'm sharing this screen with you because for the most part, whenever we invite you to come to a session like this, essentially we are speaking to and responding to issues related to STEM technologies, digital technologies, as part of what the faculty is doing, led by our dean, Dr. Muki, who is also here. Some of the things we specifically pay attention to, of course, we cannot look at everything, but there are a few things that we are looking at. We're trying to address this issue, particularly in our rural setting. And from time to time, we do look at it from the point of view of urban setting or peri-urban. So essentially, if you look at what we do, so we basically look at mathematics and computational cognitive enhancement. That is one component of what we do or we look at. We also look at STEM cognitive enhancement through human-computer interaction. And these are the two arms from which we tend to look at our research. And possibly within these two, the first one, we look at mathematics and computational cognition. We tend to also look at STEM cognition. We look at cognitive computing and modeling, which you would find from time to time if you tend to work with us or if you tend to collaborate with us. These are some of the things we look at. And the second arm, which is actually STEM cognitive enhancement through human-computer interaction, we seem to have limited ourselves to understanding pedagogical issues and cognitive issues related to mobile computing, and that is to say M-learning or e-learning. Because of the pervasiveness of technology and AI, we tend to extend a little bit into AI in digital education. And of course, talking of AI, that doesn't limit us to just AI, but we zoom into machine learning and we also look into digital technologies. In fact, some of our postgraduate students, doctoral students are looking at various technologies as I've mentioned or listed them here, Sketchpad, GIS. Some of these, we have already used them in assessing cognition already related to mathematics, but these are some of the things we look at in the faculty. And a few of other, technologies that I won't be able to mention here. But kind of speaking about this because in future, if colleagues wish to work with us, possibly these are some of the areas that we tend to look at. And I think one key thing that I also want to share with you, especially Doug being here and colleagues listening to us, I think one component that I want to share with you here is quickly this. I'm trying to pull out our projects. I think it's here. I'm trying to pull it out. It's good. So essentially in total though, our projects seem to be classified under two arms. We have the computational cognitive enhancement through cognitive or adaptive e-learning, if you look at some of the work we've done so far. And the second part, which I think, and I want to say, most of what we are doing currently seem to be speaking to the second project, that is mediating STEM learning with adaptive e-learning technology. So regardless of whether we are working alone or regardless of whether we're working with Professor Douglas or any other person, most of the time what we tend to do is to feed into this particular second project. And those of us who tend to align ourselves with the principles of scholarship of teaching and learning, we do work with our own students here, pre-service teachers. And so I think it's also in line to say that we do work with our pre-service teachers. That is to say, you might also come across some research work that seem to be informed by our pre-service teacher. And that is why I'm saying those of us who tend to align ourselves with the principles of scholarship of teaching and learning, we are not excluding our pre-service teachers, that is our undergraduates. So we are not particularly working only with postgraduate students, but we tend to go a step back to also look at what our pre-service teachers are doing. So, well, as part of the problems we're trying to solve and the challenges we're encountering, this is actually why, I invited Professor Douglas to speak to us and possibly speaking to second project. I've known Professor Douglas for a couple of years now before even joining here, and he's been a good colleague who wants to support some of what we're doing. So hopefully in future, those of you who would want to work with us, we are open. It's a team. I'm not the only one. Our postgraduate students are there. My colleagues are also part of this, and we hope to see how we can work together on some of these challenges we face in our societies. So that is why, in fact, Professor Douglas is actually speaking to one of the teams. But before I talk about our speaker, I'm going to allow our dean to share a few views, ideas with us that she's got. And before possibly I start talking about our speaker, who would now take the rest of the time. So please bear with me. Allow me to first invite our dean to share a few words with us before. I know she's also equally busy. I have to quickly squeeze her hand in to speak to us. And possibly she shares a few words with us and Professor Douglas and all listeners who are here. Thank you very much, Dean, for being around. Now hand over to you. Thank you.
All right, thanks, Prof. Bayaga. Good afternoon, colleagues. Prof, if you could just stop sharing your screen.
Oh, yes. Actually, yep, there we go.
There we go. All right, good afternoon, colleagues. I am excited to be welcoming Prof. McDougall. I'm happy to see your face now, because that's why I said Prof. Bayaga should stop sharing. At least I can see your face. I would have loved to welcome you in person in South Africa, and I assume that you would be excited to come this side, to visit us. However, I would just like to say welcome to everyone, and thank you for accepting our invitation to have this kind of discussion. And I know and understand from Professor Bayaga that you already are working, with him. And I hope that you'll work with more colleagues in the faculty in terms of STEM. And I particularly like the metaphor that you're using, not being a person of mathematics or science myself. I'm in the languages and the social sciences. So sometimes Prof. Bayaga and colleagues speak Greek to me when they throw these terms around, science terms and technology terms. I would just like to say then, Prof, welcome. And to the colleagues also welcome. We are really trying to build, the scholarship around mathematics, science, and technology within, the Faculty of Education. And I'm grateful that Prof. Bayaga has come in, and taken up the responsibility of being the leader of our disciplinary team. So we work in different disciplinary teams, but we also have research themes. And, mathematics, science, and technology is one of our research themes as well in the faculty. So I'm not going to waste, colleagues, your time, but just really say that I am very grateful for the kind of work that you are doing. And I see that Vuyani and Makosi are also here, who are part of the disciplinary team. And I was hoping to see more colleagues, but as Prof. Bayaga has said, most of them are teaching at this time. And I'm so happy to see you, Prof, in your tie. So early in the morning, but we really appreciate, your time. I'm really looking forward to your presentation. I might step out at past because I need to drive to campus so that I'm ready to for another meeting that is face-to-face. But just bear with me when I disconnect at past, but I'll reconnect again when I'm in my office. So thank you so much. I'm looking forward to the colorful flowers. I want to understand what those colorful flowers are. I have some kind of understanding about the roots and the stem and what that entails, but the activities that are happening, which are something that most people from other fields are seeing, I think that is important if you can, elucidate more on that later on. But with those words, thank you so much for your time. And thank you, colleagues, really for connecting as well. Isabel, I see you that you are here. We work with you as well in the STEM, within a different faculty, which is the Faculty of Science. But I'm really grateful that you are here, because really we would like to have this cross-cutting interdisciplinary engagement within the institution, because what we are dealing with here is something that is important that everyone needs to learn from and benefit from. So with those words, I was only given 5 minutes, so I am sure that I've only used 5 minutes. Prof. Bayaga, thank you so much for the time. Thank you. Over to you.
Okay, thank you very much, Dean, Madam Dean, for actually also making time. I know you'd always be running around with lots of meetings and other stuff to do. Now, colleagues, bear with me to also spend a couple of minutes speaking a little bit about our speaker, just in case in future you want to have an idea as to how kind of meet him and talk to him and have an idea as to what he does. Look, those of you who tend to publish and write, I'm sure you would have come across Professor Douglas even before me because of one of the things I will be mentioning here. He's actually a professor of mathematics education at Ontario Institute for Studies in Education at Ontario University. He is also the director of the Center for Science, Maths, and Technology at that center. And of course, the reason why I said some of you might even know him before me, he is an editor-in-chief of the Canadian Journal for Science and Maths and Technology. I mean, one of the reasons how the route how I even got to know him was through working and publishing in the journal. He is also former Associate Dean Programs and former Chair of the Department of Curriculum and Teaching and Learning. Of course, Prof's achievements as a scholar and as a mentor of young educators are really great. During his time as a faculty member at the center, he has actually supervised over 50 doctoral students and 22 master's students to completion. And of course, also working with us and externally examining some of our work. You would also notice that currently also supervising 15 doctoral students. So it's great to really have him on board and to have a look at some of what we're doing. He provides his students with guidance and opportunity, which of course we're hoping to tap into some of the opportunity, which seem to have also led to us working with him. And he's worked with a number of other universities, some of which we have listed: Ontario Tech University, Queen's University, and University of Toronto, and other universities in UK, US, and Australia. Some of the key things I thought I should also add here is that he has been a member in the Department of Curriculum and Teaching and Learning for over 2.5 decades, and also an educator for 4 decades, So vast experience. It's good to have him on board and for him to share some of his experiences with us. He's also a recipient of the School of Graduate Studies Doctoral Supervision Award, and hence you would notice that those of us who are aware of this, he tends to look at or examine our postgraduate students' work. And also the department is also received awards in terms of excellence in graduate education, and Ontario Institute for Studies in Education and a Mentor of the Year Award as part of the Center's Alumni Leaders and Legends Awards program. So there you go. Quite a lot to experience from him. We hope that this won't be the first time, in fact, speaking to us on such a platform. I know he's already working with us, but from time to time, we hope to also invite him or other faculties to kind of tap into his experience, and we'll learn a lot from him. So with this, I'm going to hand over all of us into the hands of Prof to have a conversation with us regarding his topic. Thank you very much, Prof. I think at this point, you would be able to take over the screen and share your work with us, and we'll listen to you for the rest of the time. Thank you.
Oh, good morning, and thank you very much for the generous introduction. It's certainly my pleasure to be here, although, as the Dean mentioned, my real great pleasure would be to be there and to actually be in person as you're putting together and having an opportunity to spend time together. Thanks, Anas, for the generous introduction of the things that I've done. It's quite interesting to listen to somebody read about all the things that I've done, and I feel, wow, that's a lot of things to be busy doing, particularly since I'm going to be starting again this coming July as chair of the department. So they've asked me to recycle my way back, and I've already been a program coordinator. So I'm presenting this session from Toronto. Thanks very much to the Dean for her generous invitation and comments about STEM and the work that I'm doing. And I do really want to talk a little bit about flowers. And it's a good time here in Toronto because we are just, excuse me, just starting into our spring. And I know you're just well into your fall and having winter coming soon, but we're just starting our spring. And so I thought I'm going to make it connect to some of those things that are there. I also wanted to mention that there are quite a number of links between what's happening at your university and what I've done. My doctoral study many years, 25 years ago, was actually using Geometry Sketchpad just as it was being introduced. And I was focusing on using that with middle school teachers and learning about them. And now I'm also have had a couple of GeoGebra conferences that I held at the University of Toronto. So in terms of the agenda, I'm going to do, and then we've had a little bit of an introduction, I'm going to actually do a story and talk a little bit about the roots, where we started, some of the research findings. I do want to think and talk about these principles of what STEM focused classrooms look like, some characteristics of successful STEM classrooms and activities, and then some of the challenges that we have. And we're going to end up with a bouquet of flowers that we're going to lead with. But let's start with a story. And this is a story, it's called A Little Boy by Helen E. Buckley. And it's about 100 years old. So here's part one of the story. Once a little boy went to school. One morning, when the boy had been at school for a while, the teacher said, "Today, we're going to make a picture." Good, thought the little boy. He liked to make pictures. He could make all kinds. Lions and tigers, chickens and cows, trains and boats. And he took out his box of crayons and he began to draw. But the teacher said, "Wait, it's not time to begin." And she waited until everyone looked ready. So as we think a little bit about the roots of STEM, let's go back and think probably in 1990s or so. Science education, mathematics education, and technology education took on a significant role in discussions about how do we address current and future social, economic, and geographic, and even political challenges. So the focus on these three subjects, with the later addition of engineering, intensified as global competitiveness increased. Countries then started to pay more attention to international exam results, such as the Program for International Student Assessment, known as PISA, and then the Trends in International Mathematics and Science Study, known as TIMSS. The policies around STEM have developed differently in different nations, and that's why it's really interesting to take a look at what's happening in different places around the world. Some of the policies have been designed to address combining labor markets and focusing on international competitiveness, for example. Maybe they've been focusing on workforce strategies and even research and development, maybe quality and education, and perhaps even emerging industry competitiveness development. In 2019, Freeman, Morgenson, and Tyler suggested that STEM education and research is fundamental to the national development and productivity, economic competitiveness, and social well-being. So as we know, all of the economies of many countries are interconnected, resulting in a variety of competitiveness and business opportunities. So this has led us to think that we need to have an educated workforce. And so if we're going to have this educated workforce, we're going to find ways and think about ways of innovation, creativity, and technological advances that are necessary to focus on these industry, society, economics. And that then led us to think that we needed to focus on STEM and consider the motivations behind STEM. So there have been a number of strands that have developed about STEAM, but I refer to it as STEM. So STEAM is one of them, which is STEM with the addition of the arts and humanities. And it's been really an important one, particularly in Ontario, because we're trying to find, as the Dean says, indicating that the literacy, how do we bring in some language? How do we bring in the arts? How do we bring in different ways of thinking about these important STEM topics? There's also ST squared M or EAM. That's science, technology, transformational learning, engineering, arts, and mathematics. And this is where we started to look at this transformation in science education. And it gives us a slightly different perspective than what we normally would have even in STEAM. There's also one that's STEMS, which is science, technology, engineering, mathematics, societies, and the environment. And in many cases, when we're focusing on science education in North America, we think of it as science education and also societies and environment, and how we might focus a little bit on social justice and environmental sustainability. In this variant, students are learning about and preparing for eco-justice issues and solutions. And then there's STEM with the extra M on the end, STEAM with the extra M on the end. That's science, technology, engineering, art, mathematics, and medicine. And this is the modification where we're learning in post-secondary education about medicine and how medicine can benefit from taking a look at STEAM or STEM issues. And I'm going to talk a little bit about the journal that I indicated that I'm the editor-in-chief, the Canadian Journal of Science, Math, Technology, Education. And occasionally I'm going to link up some of the things that I say to that journal so that you can see where I'm talking about. So there's a very good example of this last one, STEAM with the extra M on the end, in issue 21.2 in the journal, 20 meaning volume 22, so it's 2021, sorry, 21.2 is in the year 2021. So there are many definitions. And so we as authors and educators and researchers and stakeholders, we need to clarify what we mean when we talk about STEAM and STEM, because sometimes we have different definitions. Let's continue on with our story. So now, said the teacher, we're going to make flowers. Good, thought the little boy. He liked to make flowers, and he began to make beautiful ones with his pink and orange and blue crayons. But the teacher said, wait, I will show you how. It was red with a green stem. There, said the teacher. Now you may begin. The little boy looked at the teachers. Then he looked at his own flower. He liked his flower better than the teacher's. Excuse me, but he did not say this. He just turned his paper over and made a flower like the teacher's. It was red with a green stem. So we start to think about some of the research that has been done and being generated now, and I'm thrilled to see the generation of research coming out of your center. We see that the boy made a red flower with a green stem. Let's think a little bit about all the possible flowers that could exist, and even in the research. So in 2014, in the issue 3 of the journal, Rod, Rice, and Mujaba investigated why good students select to study subjects other than STEM. They were taking a look at the unconscious forces that influenced the decisions that were being made about students in their further study. They looked at the role of commitment and the beliefs about being good enough. And the question that they also heard often is, am I good enough? Am I good enough for mathematics education, for science education, for even STEM education? And so as they were thinking a little bit about it, they did another study in the United Kingdom, and they investigated the importance of teachers' encouragement on choice. And they found that statistically significant correlation between teachers' encouragement to consider mathematics after age of 16 and the students' future intended choice for mathematics courses, especially in grade 9 to 12. And they found out that a really important component was the teacher and their role in encouraging students to select and investigate and learn more about these subjects. So I think a little bit about my personal choice. And when I was trying to decide on the university, I started thinking a little bit about, okay, so what might my choice be? And I had a variety of different universities that I could go to. But the question I had was, am I good enough to study math education at university? And as I was thinking about this, my senior year teacher said that he thought I was good enough. He had confidence in what I knew and what I could learn. And so I selected the University of Waterloo here in Canada, graduating with an honors Bachelor of Mathematics. And since then, I've been drawing flowers of many shapes, colors, and sizes in my time. So back to the journal. In 2019, Murphy, McDougall, Lang, and Denia investigated the role learners' motivation and emotional support in STEM played in their participation and achievement in STEM education. They focused on gender and revealed that self-concept, self-efficacy, and task value were important components. They also found that girls had a lower self-concept in STEM. They were likely to hold less interest or value in STEM, and that they were more likely to attribute their failure to a lack of ability. Finally, they found that these negative emotional responses to STEM were be understood and addressed part of a successful strategy to figure out how to improve STEM education, involvement, and to think quite a bit more about significant gender equity and issues around STEM. In 2016, there were a group of researchers in math and science education who co-edited a special issue in the journal about STEM. And they had 7 articles in there about what is the purpose of STEM education. Are we educating our students with the intention that they gain wisdom and knowledge and become active democratic citizens? Do we see education as a means to prepare a workforce that can innovate and to compete globally? And so there's quite a number of really interesting articles in there, including one that was taking a look at Indigenous and Western ways of knowing, being, and doing. We have a really important component here in our education about Indigenous education and thinking about those First Peoples in Canada before people arrived here. And what they were suggesting that if we were to move away from this economic perspective on STEM and more to STEM as an artifact of teaching and learning, that we start with explorations. Then we move to questions and conversations about an opportunity for students to see themselves as competent learners in mathematics and science and to engage in these Indigenous perspectives. We also had, as I talked one more time about the journal, in 2020, we had one called Reimagine the M in STEM. And what they did was they focused on what the 2017 STEM learning framework that we have here in Canada. And that report invites teachers to learn about Indigenous ways, about STEM integration, and finding ways to close this gap that we have in some of the work that we're doing in science and math education. We also learned that one of the key participants in research are the students. So there's another article in that same issue about grade 7 students and some of the work that they've been doing to think a little bit about their own self-perception of competency and interest in science and math, their engagement in STEM, their activities outside school and how that knowledge can be integrated into the school, these students just didn't seem to understand the importance of science and mathematics in their future STEM careers. They thought they could just go into STEM without having that background. So this research helped us to learn a little bit more about what students were doing in high school so that they could learn more when they get to university. We also had a number of STEM authors who motivate and engage students. And some of you may know Lynn Carter of Australia, who writes about STEM, very well known, and she's taking a look at how some of the features of the Australia's position on STEM and the policy agendas of the university, and how it's quite a bit driven by the government of the day, not necessarily by the education. And so she thinks that science education is missing this critical studies about how these policies on STEM would influence what's happening in the classroom. And so she started to look a little bit at comparisons between different countries. So let's go back now to think a little bit about this story. So continuing the story, on another day, when the little boy had opened the door from the outside all by himself, the teacher said, "Today we're going to make something with clay." Good, thought the little boy. Snakes and snowmen, elephants and mice, cars and trucks. And he began to pinch and pull and pinch his ball of clay. But the teacher said, "Wait, it's not time to begin." And she waited until everyone looked ready. "Now," said the teacher, "we're going to make a dish." He liked to make dishes. He began to make some that were all shapes and sizes. But the teacher said, "Wait, I will show you how." And she showed everyone how to make a deep dish. There, said the teacher, "Now you may begin." So let us build a little bit of a clay dish. What are some of the characteristics of that dish? What about the shape, the size, the color? So let's just examine this teacher's classroom for a few minutes. She had a great idea that she wanted to engage her students in to build something, to make something out of their hands. She had the students were asked to use their hands, as I mentioned, and maybe a model or a representation of something. In the first case, it was a flower. In this case, it was a clay. But we also wonder a little bit about the beliefs of this teacher. What did she want the students to know after this activity? Does she want them to learn to wait? Does she want them to learn to do what she does? Does she direct her teaching to having the skills that she wants, or is it her only teaching strategy? Is there anything else that students can do to explore on their own? So while we don't know what the teaching plan was of the teacher, we know that teacher beliefs play a really important role in successful implementation of STEM. The teaching of STEM integrated unit requires a lot of investment in time and energy. It's not easy to put together an activity that you're going to bring together science and math technology ideas and concepts. You need to be able to find ways to look at the different curricula, look at some examples, build a model, create a project. Studies have shown that teachers who believe in the importance of integrating curriculum report a higher level of success. So if the teachers are invested in this philosophy of integration and it fits with their vision of education, then they're going to be more successful. If they don't, then they're going to find it quite a challenge to integrate if they believe in these silos of individual subject areas. One of the really important questions for me is, how do we support teachers who believe that STEM education and integration are really important, but they're just a little insecure in their ability to integrate it into teaching practice? So maybe there's a good time to look at a framework of successful STEM activities. There are a number of that we can use in the implementation. I'm going to spend a few minutes on the one that I like, which is a theoretical framework by LaForce et al. In 2016. This framework can provide us with a model that will inform research and discussion about STEM. The framework emerged from the research that they were doing, and they were focusing on high school. So I'm going to set that up. It will look different in elementary school, and of course look different at pre-service teachers or in university. They had 8 elements of this framework. There were 4 instructional elements. They called personalization of learning, problem-based learning, rigorous learning, and career, technology, and life skills. And there were also 2 non-instructional elements, the school community, belonging to that school community, and the external factors. And then 2 supporting elements, the staff foundations and the essential factors that they refer to. So that gives me the 8. I'm going to just take a moment to talk a little bit about them, because as we think about a rural school or rural school area, then that school community and belonging is a really important one. So the personalization of learning means that learning is going to be adapted to each student and their interests and their skills and their knowledge. And so we should be focusing a little bit on individual learning, and to use scaffolding, which is starting off where we start to integrate a little bit about maybe giving some students a wide open question to do, where other students might have step-by-step examples of how to get to the final project, for example, because they need a little bit more guidance along the way. We also want to find activities that have a varying degree of challenges, so that the students in degree of difficulty, I guess would be a better word, and then familiar context so that the students understand the area. So I'm right now in urban Toronto. So some of the examples I use are from an urban context, but I am also doing research in rural schools, and I use the rural context for there. So adapted to the students. There's also a problem-based learning, which is an instructional strategy and approach that requires students to solve a problem, and they have a learning goal. They might be focusing on something that they could do in one class. It might be a long-term activity, so it takes a little longer than that, but they're really looking at tasks or activities that are focused on real world context, so that they can illustrate the importance of different social issues, medical issues, and we complement that with teacher facilitation. So the teachers are finding ways to support the students, but staying out of the way so the students can explore. A third one is rigorous learning, and that's where we focus on content that is challenging and high cognitive demand. The rigor is not the same one you find in calculus. When I did calculus, we had to do some rigorous calculating. It's not like that. It's really about the expectation that teachers place on the students so that they can engage in these challenging activities and to create an environment that provides experiences for students that will push them beyond what they normally would know. The career, technology, and life skills element is really focusing on what the skills that students might need in university or future careers or even in their own life, and giving them an opportunity to learn about different kinds of technology, about career readiness activities so that they learn about time management and communication and collaboration. The non-instructional ones are, the first one that I mentioned was about the supportive community in their school and having a strong school culture that students feel that they're supported, that the teachers care, that the administrators care, that their parents care, and that they are able to engage in different activities. For example, to do some field trips, to go out into the community, to see STEM activities live and in action. So they have a chance to think about that as a career. Is that an opportunity they would like? They might also collaborate with different communities or have professional development learning activities in their school. They have administrative support and also common planning time, so teachers can get together and do some planning. Sometimes you might need to put together a science and math teacher to integrate some of the topics because they don't know individually enough about the other subject to do that, and then to integrate technology. Another one is the outside elements of the school. And I'm not referring necessarily to snow, although you can use lots of snow in some places to make it happen. Here in Toronto, we have that. But it's really about the family, the support that they have at the school district or the province or the state support that they might have, and the designation of STEM schools, and whether or not there are locations where students can go focusing particularly on STEM. This framework has been very helpful in the use for implementing of STEM in different schools. Can help teachers understand what are some of the elements that they need to learn, what are some of the places that they need to focus on, and also provide this guidance and general structure for what happens in the classroom so that we can make sure that we're using some common language and have some flexibility to think about what these activities might look like. I'm going to just take a moment to look at a couple of studies that were actually focusing on STEM. So one of them was Lee Capero Beiser, who were taking a look at STEM and non-STEM activities in grade 9 and mathematics classrooms. And they found that the STEM students were showing a much higher degree of interest in mathematics and certainly improved recognition of the value of mathematics that they didn't have before. They were using a project-based environment so that they were able to think a little bit about working together in collaboration and also focus on student-directed learning. The teacher was a facilitator, and they found that the teacher made a big difference in the attitudes and the knowledge of the students because the teacher felt that it was an important thing to do. And then the students learned that as well. That was with the STEM students. Now the non-STEM students, they ended up actually having a more positive mathematics attitude and emotion about it than the STEM students. They were receiving more traditional instruction, as you would imagine, and that meant that there was less stress in the learning environment. They also found that everybody had a positive attitude towards STEM, but the non-STEM students didn't really have a good sense of what the value of it was. So it provided a really good way of thinking about how STEM and non-STEM students have different aspects of the engagement is activated. So that shows that there are opportunities for traditional teaching and opportunities for project teaching, and that combination would be very valuable. One of my doctoral students who just finished in 2021, Andrew Tangentko, he investigated STEM integration in 4 secondary school science and mathematics teachers. And he noticed that the most common approach was the project-based approach. And he also found that there were increases in student engagement and motivation in those classrooms and improvement in achievement as reported by the teachers. But he also found that some of the most important components of their program were the field trips that they had and the partnerships that they had with outside organizations. That was a powerful tool to complement what was happening in the classroom. He also found that there were some challenges to implementation. These teachers needed time for collaboration and they didn't always get it. They needed professional development in order to learn a little bit more about subject areas outside of their own expertise. And they needed a little bit of help in learning how to put together these projects. The very positive administrative support that they found was really helpful. And that made a big difference for them. Let's just learn a little bit more about this story. So as you remember, we're about to build a dish. The little boy looked at the teacher's dish and then he looked at his own. He liked his dish better than the teacher's, but he did not say this. He just rolled his clay into a big ball again and made a dish like the teacher's. It was a deep dish. And pretty soon the little boy learned to wait and to watch and to make things just like the teacher. And pretty soon he didn't make things on his own. So let's just think about some of the challenges of STEM integration. So we've seen some really incredible research to understand the implementation of STEM, and I talked about it just briefly today. But there are also some challenges that the teachers are going to face. And one of the most common challenges that they refer to is the difficulty in finding time for collaboration. They needed to spend extra time to create the activity. They needed time to make sure that the students had all the materials and resources that they needed. And they also needed time to share the resources with other teachers and to plan the integration of context together. Another challenge that they found was accessing professional development activities because they couldn't find them. There weren't that many people who were doing STEM integration. They didn't find it easy to look for other strategies. They looked online and they found some examples of projects, but they didn't find that element of sort of teacher involvement, teacher facilitation. What do they need to do? They also found that there was a challenge in the lack of curriculum and assessment materials. So they could integrate some projects they found online. They could use some of the materials, but then they didn't know how to assess the students, how to assess them individually, and how to assess them in the group if they were using group activities. However, what they found was that every one of the teachers had an expertise in one subject area. And so they started from that skill and building a little bit at a time. So one activity maybe per month, that was STEM. And then after a year, they might have 8 or 10 of them, and then add more the next year. So find ways to slowly integrate their program. I started teaching at a time when punch cards was the way we used to write a computer program. So the cards were sent to another school, and then the printout would come back 2 or 3 days later, and I found out that I made all kinds of errors. So I would fix up those cards and send them off again. And after I got my degree in computer science and mathematics, I started teaching computer science. And I had learned a lot about the use of technology. I told you that for my thesis, I integrated dynamic geometric software as a way of working with teachers and having them replace the compass and protractor with Geometry Sketchpad. But through most of this, I found that there are many teachers that have been challenged with the integration of technology. So while they might know science, they might know mathematics, this integration of technology was quite a challenge. So I started teaching, as I told you, 40 years ago. And so I would have expected by now every teacher could use technology, but that's not true. I found that it is even challenging to integrate technology into one subject, and now to add a second one was really quite a challenge. And so my view is that we need to have a blueprint or some method of helping pre-service teachers understand the collaboration that's needed for STEM. We also need professional development activities so that the STEM teachers who want to integrate STEM are able to work together to create these contextual relevant curriculum activities and problems. And we also learned from Tinchenko's research that this community involvement in the way of field trips is really an important component of how we might do this. But when he was doing his work and the work that I've been doing, we found that there's just no common language amongst teachers, students, and industry professionals about the integration of some of these projects. And so we've also discovered the challenges of the language of engineering. So we do need these opportunities and strategies to build these together, to find ways to integrate new ideas. And some of the work that you're doing at your center in many different projects are really important to generate the activities and the professional development that are needed for these teachers so that they can work together. So back to our story about the little boy. Then it happened that the little boy and his family moved to another house in another city, and the little boy had to go to another school. And the very first day he was there, the teacher said, "Today, we're going to make a picture." Good, thought the little boy. He waited for the teacher to tell him what to do, but the teacher didn't say anything. She just walked around the room. Then she came to the little boy. She said, "Don't you want to make a picture?" "Yes," said the little boy. "What are we going to make?" "I don't know until you make it," said the teacher. "How shall I make it?" asked the little boy. "Why, any way you like," said the teacher. "Any color?" asked the boy. "Any color," said the teacher. "If everyone made the same picture and used the same colors, how would I know who made what?" "I don't know," said the little boy. And he began to make a red flower with a green stem. So what are we going to make? What does this boy's future look like? Will he learn to draw? What does he learn from this activity? Did he just learn that he had to wait until the teacher told him what to do? Did he learn that he just had to imitate what the teacher was trying to do? So if this is an example of what might happen in some classrooms, what do we think that STEM will look like in the future? We're now in and out of a pandemic, midst of it, I guess we could say, where we sent students home to study virtually. We changed the role of the teacher from in the classroom to online. And we've also modified our curriculum, opportunities and engagement. We weren't able to do field trips in some cases for a while. And so the role of STEM is all around us, but sometimes we have to start to think about new technologies. Before the pandemic, I probably used Zoom 2 times, maybe 3 times. It was not part of my teaching. It was not part of my communication with people. And now I use it hours a day. And other technology, depending on the country I'm using. So we've seen how science works and the STEM around us, but we sometimes also want to see how it affects medicine. So in the June 2021 issue of the journal, one of the things that was being written about was the critical literacy necessary to critique government social policy decisions to set rules for behavior to limit the spread of COVID-19. So he was writing about his experience for behavior in the United Kingdom and gave examples of STEM that had a political perspective. And he was stating that the COVID-19 pandemic has brought us together and technology together and knowledge and expertise from different disciplines that normally don't work together. And part of it was to develop some of our understanding about COVID. Some of it was to help us understand how to create and to generate very quickly vaccines that might be helpful for the pandemic. And it was really a transdisciplinary example of how we had uncertain, high complexity and contested social visions. There were some who said they didn't think that we needed to. In fact, there were some that didn't even think there was a pandemic, and others who thought we don't need vaccines and they weren't safe vaccines. So this is type of problem where we have this high complexity, lots of uncertainty, not sure where we're going to go, and competing social values as a wicked problem. A wicked problem in such a way that we're not able to do it by silos. The science people couldn't do it, the math people couldn't do it, technology couldn't do it. But together, using STEM and engineering, we're able to find ways to generate a vaccine. So there are a number of issues that, as we move forward with STEM education, we should focus our mind on addressing some of these challenging problems that we have. In 2020, Brian Goosey also suggested different ways of seeding the future. They called future research, but I think to generate and to germinate some questions about to grow into some fruitful understandings. They created 3 broad areas for research. The first one was to create narratives about the purpose and the goal of STEM education, to create some case studies so that we're able to get a better sense of successful teaching that might take place in classrooms, successful projects that might work. They might also be about students and how they develop an understanding about STEM and what some scientific phenomena might develop in their lives or in other lives. Another area is about the nature of STEM. And to answer this question, we have to reflect a little bit more on the philosophy and the nature of these individual disciplines and how they might integrate to become what might be called a STEM education curriculum. And I think that this one will assess this. If we're doing this and having opportunities to integrate some of this curriculum, then we probably will come with a common language and an opportunity to share a little bit more about our own work and what we're trying to do. The third area that Brian and Goosey were proposing was exploring innovative teaching and assessment approaches that might have. So some of the challenges I mentioned was about bringing teachers together and having appropriate assessment practices. And they're suggesting that this is areas that we could come up with brand new ideas and brand new areas of studying. So these are just some examples of some of the research that can be done. And of course, it matches up very nicely with some of the things that you're doing along the way. So just before I finish this, I want to talk about flowers, a bouquet of flowers, because there's lots for us to learn from the story that we heard. Part of it is, do we expect our students to be creative? Do we expect them to generate their ideas of what a flower might look like? Because if they do, and if we do, then we will have a bouquet of flowers. They will all look different and they will all have multiple colors and shapes and sizes. And then we will end up with a variety of learning experiences that we can share with each other. It will allow us to give questions and activities that would lead to more than one answer, for example, that there are multiple answers to some problems. And in some cases, there are multiple ways to get to the single solution for some problems. But if we follow the practice that we saw of the teacher of wait, I will show you how, then that's what the students will learn, that they have to wait and they'll lose that creativity. We frequently ask students to make a flower, make a model, make a representation, make a painting, a poem, a musical contribution, composition, a short story, an elegant solution to science or mathematics, a STEM activity. And yet, often what we get is a red flower with a green stem because we've taken that creativity out. So my question is, what kind of flower do you want with your STEM activities? What have you done in order to nourish that flower, to help it grow, so that the product of your STEM activities is a bouquet and something that has a different format and a different product than what you might get if we follow what this teacher did. So thank you very much for your interest and your attention today. I know we did want to go just until 3 o'clock, so I'll just stop at this point. And thank you very much for your attention, and enjoy your flower for today.
Thank you very much. Thank you very much for the presentation, very wonderful presentation. And of course, I'm presenting it right up to 3 o'clock. It's just 2 minutes to 3. Whilst I'm sensitive to the fact that some of us will still have places to go and other stuff to do, because we said we ending at 3. I also recognize the fact that 1 or 2 of us would have a couple of questions or comments, and possibly I think Doug would might entertain 1 or 2 comments or questions if colleagues have 1 or 2 comments or questions or interactions. That would be great. I think we would want to welcome a couple of comments and questions if colleagues do have. Vianney, I see you are here. Prof. Olivia is here. I see Isabella. Any comments? I know, Werner, you're working a lot with rural students and in-service teachers, I suppose, and GeoGebra. Doug also does lots of work with GeoGebra and stuff. So if you have any comments, I think this is a very good platform to share your. Just to add up a few comments here, Werner also heads a center quite similar to what you do in that, so it would be a good idea to hear what Werner has for us.
Yes, good afternoon to the Prof and everybody else. Can I continue?
Yes, sir. Yes, sir. Yes, sir, Prof.
Yeah, maybe just 1 or 2 questions. It was interesting to listen to the story of the little boy. The fact that, for example, that he liked his dish more than the teachers, and yet he had to follow the teacher's example. Now, maybe just 1 question slightly related to that. What role do you think play?
We seem to have lost you a little bit, Vianney.
Yeah, I got the first part, which is what role, and then I lost, and I didn't hear anything out of that.
Yeah, Vianney, you have to repeat. Yeah.
Okay, I'm not sure what happened exactly. My question is, I like the story of the little boy who, even though he liked his own dish, but had to follow the teacher's example. He had to do as he was told. Now, the question is, what role does play in the classroom situation? Does it have any role to improve learning in the classroom situation? So play, I mean, the use of game-based learning.
Yeah,
and other activities related to that.
Yeah, thanks for the question. I think it's a really important question. I'm very much into the idea of play. Every time that I provide a new manipulative or concrete materials to students, I ask them to play. And I do the same thing with teachers. I taught pre-service teachers for the first 10 or 12 years of my career at the university. And so for every case that I would give the students. So yes, when the teacher said we're going to make a flower, that would have been a perfect time to play. Make whatever you want to. If the teacher had some other teaching learning goal that they might have, then they could do it after the student had an opportunity to make something, and then say, okay, now we're going to make it that it has these colors or this shape or whatever parameters the teacher wanted to put on it. But yeah, I think it's really important. Games, I play games with my students in elementary school when I was teaching elementary school for 9 years, secondary school for 8 years, before I got into university. And then while I'm still in the university, I had a course that I taught this term, just in the winter term here, which is our January to April. And every day that we had a class, we were playing games. We had a game of some type. We had an exploration of some type that they were just to play. So to me, it's the start of every learning activity. Just start with play.
Okay, thank you very much. Maybe just another question related to your presentation. In this country, probably in many other countries, I don't know. We do struggle to attract some of the best math students to education, to get them to become teachers for different reasons. Is this the same problem that you're having in your country? And what do you do to attract students to maths education in particular?
Yeah, that's a really good one. We do have that same problem. I went, as I said, to the University of Waterloo, and many of my classmates went on to be actuaries and accountants and professors and other things in math, but they had a teaching option, and I was part of that. And so it was a small community of us that wanted to go into teaching. One of the things that we did in Canada, at least in Ontario, is we changed the focus of the importance of teaching. So at one time, teachers were paid very poorly and were not given many opportunities to do certain things inside and outside of teaching. So one of the things that was changed is that we increased the value of the teaching through the salary that they got, and we provided more professional development so they could become better teachers, and gave incentives for teachers to get master's degrees, doctorate degrees by paying them a little bit more. So there was a social change, was one thing that happened. The other is, in my university, is that at University of Toronto, is that we actually were looking for those who wanted to become teachers. And so we set aside a certain number of places in our program for those who wanted to teach middle and secondary school math. And so it was a little easier for those students to get in, because in the past they found quite a bit of a challenge getting into the teachers college, because there were so many other people that had experience teaching elementary school, for example, or not necessarily teaching, practice in classrooms or working with other teachers. And so we found that we needed to find a path for those who really wanted to be teachers and to focus on math. So those were just some of the things we did.
Okay, thank you. Can I ask the last question regarding the personalizing learning? Is this really achievable? And if so, how? I mean, do we make use of the technology to personalize learning? Because it does seem as if, even though many strategies have been tried in the past, and we don't seem to be finding that one strategy that seems to work for everybody. So it does seem as if personalizing learning could be the way to go. But in practice, how would you go about doing that? Thanks. That's my last one.
Yeah, that's a really good question, because it has, if we knew that there was one way that we could teach everybody, then we just have to teach that one way. We'd all do it. We'd be happy and everything would work well. So it doesn't work that easily because of the experiences that students have. So one of the things that we've been working on in grade 9, I'm working with grade 9 schools, is in the past, grade 9 used to be streamed. So we had what we call an academic stream, and we had an applied stream. So the academic students went to university, the applied level students probably went to college or went to workplace. And so it was easier to individualize because we'd already split them into 2 and sometimes into 3 groups. Starting this past September, we put them all together. And so the teachers are struggling with trying to figure out how to give individualized programs for the students. So what we're doing to try to help them do that is, rather than think of giving every student the same activity, is to think about what are some of the big ideas in mathematics in grade 9, for example. And so some of them are that you want them to be able to solve linear equations, but they don't have to all be the same level of linear equations. So they have been using technology as a way of generating questions for students to solve based on, in some cases, 1 to 5 or 1 to 10, that the student puts in to say, I think I want a question that's level 1 or level 3. the program automatically generates a question that might be at that level to give students slightly different ones. That works fine until you end up with 30 students in the class and everybody has a different question. You can't answer all of their questions. So they narrowed it down a little bit to find ways of providing students with a question which has the scaffolding. So some students will get a question that just has the posing the question. Others might have a one-by-one step along the way to say, oh, do this. What happens when you do this? What happens when you do this? So they might have 2 or 3 questions in between to solve on their way through it. And that's what they meant, what I mean sometimes by individualized, not completely everybody different, but just that some need more support than others.
Thank you.
Thank you very much, Dr. Macha, for all those comments and questions and the responses from Doug also. I believe that right now you are ready, and I think you want to ask a couple of questions or interact with Doug a bit. So please go on, please. Especially that your centers seem to speak to each other.
Good afternoon. Thank you very much, and thanks a lot, Dr. McDougall, for the very interesting talk. Unfortunately, we don't have too much time, but there's no silver bullet, no one solution, as you mentioned. I agree. I do agree with you also that teachers are so critically important, and in South Africa we have unique sets of circumstances, and we try to incorporate the good research that you referred to and other things in a practical way to try to assist, particularly with the integration of technology. I'm quite passionate. I'm a maths guy, so I'm quite passionate about GeoGebra and all that. We got some strong international links with people from Finland and so on. So I do think there are innovative ways that one can try and stimulate interest, but also to capacitate teachers to utilize 21st century approaches to really be more effective and at least to engage in a more meaningful way. And you've mentioned some great examples. So thanks a lot. I don't want to ask a question. I just want to comment. I found it very interesting. And hopefully in future, we can also, exchange more, about the work we do. In the center that I direct is more towards practical solutions linked to the delivery of the curriculum in the school system, with professional teacher development also very close to our heart. But we also embrace STEAM education since 2017 with the influence of our colleagues in Europe and so on. And I think that's great, learner-centeredness and the whole thing about the teacher not becoming a facilitator, rather, where technology plays a very important role. So I do think there are wonderful things that overlap with what you said. So thanks a lot again from my side.
Okay, great. Thanks very much for your comments. We did see this as sort of getting started and having an opportunity to start getting to share some ideas and etc. And thanks also for being in a classroom to share the background. As you see, I just have this straight University of Toronto thing, but I can actually feel a little bit that I'm there right now. I can see some of the graphics behind you, and it adds just a little bit more. I really was thinking of having opportunities to get to South Africa. I've never been there, and it would be a really wonderful opportunity to share some of the things. It's good that we do have Zoom. We can continue to share some ideas, and this, I think, is just a beginning point. If there are times when you have meetings or different activities with teachers, then certainly, it's fine early. It's not that bad time here. Anytime from 1 o'clock in your afternoon through the rest of the day fits my schedule pretty well. So anyway, a really great opportunity to get, quote, here with you and to learn a lot. And and I have been communicating back and forth and wanted to set this up. So thanks very much.
Thank you from our side. You're always welcome here, and we'll keep you in mind with any of the activities that we plan as well that you may be interested in. Thanks also to Anas for arranging this. Thank you very much.
Okay, thanks very much, and thank you very much, Doug, for your time, your patience, and all the communication and preparation. I know you had to forgo a couple of things to get to this place and spend 1 hour with us, and I'm pretty sure not just 1 hour. You spend quite a lot of hours preparing and getting here. It's almost like teaching. We often say you go in there for just 35 minutes. Actually, not 35 minutes. You would have spent almost 2 to 3 times the time preparing to come to the class. It's just the 35 minutes that we see. So really appreciate it. Like the Dean also said, On her behalf, thank you very much. I'll still send a formal thank you to you, but on her behalf, I'm saying thank you to you, and that we really look forward to working with you and your center. And like Verna also said, Verna is running a very good program there in his center, and in future, I still have a second meeting to meet him. I've also just joined the university and we're trying to see how it works. I mean, with the bit of history I have with you before joining here. So you would see in future, we hope to see how we can work collaboratively. Vianney is also one of my maths colleagues and a few other maths colleagues that are not here. They've sent emails and saying that they will not be here, but they would love to have your talk. Fortunately, you don't have to send it to me because it's being recorded. I would send your talk to them and they would listen and of course upload it online on our site. So in future, there's a good chance colleagues would throw back and forth emails to make a follow-up on your talk. And thank you very much. We'll speak behind the screen later and I really want to wish you well. And of course, I know it's online and I wouldn't say drive safely, but stay safely online and hope to talk to you pretty soon. And colleagues, Isabel and of course Bruce, thank you very much, and the colleagues who of course are yet to listen to the session at a later date, because I know they will definitely come back and request for the link and to listen to them. And also one of the things we do, we send your link to our students to listen. Majority of them, in fact, they have their sessions this time. You remember the first time when I proposed the time, I said in the morning, and you seem to have corrected me to say, let's make it afternoon time, because in Canada it would have been morning. And the reason was because usually we have good number of students, attendees around about midday, before midday. That was the reason why I set it up. But we'll definitely send your link and your talk to our colleagues and students to listen, and don't be surprised if in future they want to have a talk with you or listen to you again. But for now, thank you very much. I see it's 3:15 here, and that might be 9:9, I suppose. So I want to say goodbye and stay safe, and I would write you again. Thank you very much, colleagues.
Great, thank you very much. Bye.
Okay.
Thank you very much. Bye-bye.